Okay, here's another example of a reaction mechanism type problem. So what we're looking at is our reaction as being C2H4 plus I2 gives C2H4I2, and our rate equation is C2HK, C2H4 and then I plus. Now the first thing is the reaction one step or more than one step? Well, clearly we don't have any I plus in our actual reaction, so there's no way that it could be just one step. So we know that not all the reactants are in the rate equation. So what would it be if it was one step? Well, it would be C2H4 and I2. So whatever is involved in the reaction would be in the rate equation, so that would be one step at that point. But that's not the case. So we know that this is involved at some other point in the reaction, this I plus here. Now the first thing we want to do is figure out, well, first of all I'll draw my, like I usually do, I'll draw in my actual reaction, the one we actually want to add up to. And what I want to do now is figure out whether this I plus, this C2H4 I plus, is going to be the first step or is going to be some other step down the line. Now, as I've said in the past, if you can take the whatever's in the rate equation here and pull it directly from the reactants, you can pull the C2H4, but what about the I plus? The I plus I can't pull from the I2. It has to be exactly in here. There's no I plus anywhere in the reaction. So what that means is that the I plus must be formed in some other step down the line. So what that tells me is that the slow step must not be the first step. And again, it's because I cannot pull whatever's in the rate equation from the actual initial reaction. So what I'm going to do is I'm going to do my slow step now. It would be not the first step. It would be C2H4 plus I plus, and that's my slow step right there. Alright, so the question would be, where does the I plus come from? Well, the only place it could really come from is from the I2. It certainly couldn't come from the C2H4. So what I'll do is I'll get the I2 and I'll form the I plus from there. Then I've got to ask myself, well, what's going to form along with the I plus if I start with I2? Well, it's going to be an I, but it has to be I negative. And the reason for that is because the positive and the negative will give a total zero charge over here, and we've got a zero charge over here. So we must keep things balanced for charge all the way along as we do this. Now we've got our I plus explained, and that's going to cancel when we add everything together. The I minus is going to have to add up somewhere else along the line as well. Now what I've got to figure out is some kind of product of these, and what I'm going to do is just make it C2H4 I and then a positive charge. So it has to have a positive charge on it because everything over here adds up to being a plus 1 charge. We've got 0, we've got plus 1, so that comes out to plus 1. Now this comes out to plus 1 as well. So that's one way that I can do that that's going to work out. Notice I couldn't form C2H4I2 because I didn't have enough I's to do that. So I just was kind of stuck with C2H4 and C2H4I plus over here. Now since I don't see any C2H4I plus anywhere in my final reaction, I'm going to have to react that down here as a reactant in the last step. We'll do that. There's also one other thing I haven't explained, and that's the I negative, and that's going to have to go as well. So that will get cancelled too. And not coincidentally again, that's going to add up to give C2H4I2. So that will be a valid reaction set as well, so that'll be fast, and that'll be fast. And again, I want to highlight the importance of being able to tell when the slow step is not the first step. And again, what I did was I looked at this and I said, well, C2H4 and I got I plus. The I plus has to come from somewhere. It certainly didn't come from the initial reaction because I2 then can give the I plus, but we're going to have to put this in some kind of second step once the I plus has been formed in some kind of previous step.